Hello and welcome to today's lesson where I'm looking at sine and cosine. So to start off, I've drawn a right triangle, and relative to this angle I've labeled the opposite side. It's across from the angle. Okay, so if we go across, opposite, and then across from the right angle is the hypotenuse, and then the remaining side is the adjacent. We've seen that the tangent of angle theta is the ratio of the opposite length divided by the adjacent length. But there are two other trig ratios that we haven't looked at. One of them is called the sine, and the sine of theta is defined to be the opposite length divided by the hypotenuse. So that's the sine. And the other one is the cosine of theta, which is defined as the adjacent side length divided by the hypotenuse. So these are the three trig ratios that we work with, and there's an easy way to remember these, and it's called SOHCAHTOA. I'll tell you what that all means. If you haven't already figured it out, you look at this and the S is for sine. So the sine is defined to be the opposite over hypotenuse. The cosine is defined as the adjacent over the hypotenuse, and the tangent is defined as opposite over adjacent. So if you just remember SOHCAHTOA, then you know exactly how sine, cosine, and tangent all work. So let's get on with some actual numerical examples here. So in my first example, I'm just going to draw the triangle for you. Let's say we had a situation where got a little right triangle here. And let's say we know that this angle is 28 degrees. And we know that the hypotenuse has a length of 35, and we would like to figure out this side over here. It's a really good idea to label which side is which, so let's do that. Across from the right angle, this is the hypotenuse. Across from the 28 degrees, this would be the opposite, and that means this guy down here is the adjacent. Now, here's the thing. We know the length of the hypotenuse, and we want the length of the opposite. So if you think of SOHCAHTOA, so if we write it all out, you have to look for which trig ratio uses both the H and the O. And that's going to tell you to use sine. The other ones use adjacents, or yeah, they both use adjacent. So the one we want is sine. So I set up my trig equation. The sine of 28 degrees is equal to opposite, which is x, divided by the hypotenuse, which is 35. Now I've got my trig equation. All I got to do is solve it, and the easiest way to do that is to make this a fraction, and now I can just go ahead and cross multiply and divide. So to get x on my calculator, I'm going to go 35 times the sine of 28. And to two decimal places, I found that number to be 16.43. So that's trig in action. Let's do one more example. And then I think that will suffice. So the next one here, I'm going to draw a little triangle. Something like this. Okay, that should be good enough. Now suppose we want to figure out angle A. And I'm told that this side here is 15 and this side over here is 24. So again, first thing you want to do is figure out which side is which. So across from the right angle, this would be the hypotenuse. Across from the angle, this would be the opposite, which means this last side is the adjacent side. So when I look at it, I can see I know the hypotenuse and I know the adjacent. So if I go to SOHCAHTOA, I'm looking for the trig ratio that uses hypotenuse and adjacent, and in fact, I just wrote it. It's cosine. So now I'm going to set up my trig equation using cosine. So the cosine of angle A is equal to the adjacent side length divided by the hypotenuse length. And all I got to do now to solve for the missing angle to get angle A is I'm going to put this ratio into cos inverse. What you're actually doing here, by the way, is this. The reason we use cos inverse is we go cos inverse of both sides. And what happens is an inverse function undoes a function. So cos inverse and cosine, they kind of undo each other. That's what inverse functions are all about. So they've killed each other off, leaving just angle A. And so the work on the right is cos inverse of 15 over 24. And when I do that, I found I got 51.3, or to the nearest degree, I could just say 51 degrees. So that's my answer for angle A, and that completes it, and that's where I'm going to stop. So with that, I will stop, and we'll catch you later.